Welcome to a fabulous Friday, everyone. Thank you for showing up for your learning and for showing up to correct your Unit 4 test on linear relations. Regardless of if you're going to grade 10 academic or applied, the linear relations unit is going to be extremely applicable to all of the content in grade 10, even more so than other units. You can think of it as a kind of climax of the grade 9 curriculum. So let's go ahead and take a look at all of the different topics. And I'll go fairly quickly through interpreting graphs. For this graph here, boop, turning on my equipment. Okay, my equipment's working. For this graph, we want to see that distance from the surface versus time is being compared. And we have distance from the surface on the y-axis and time along the x-axis. We're told that Nevenka and Juan are scuba diving. Nevenka is a solid line. So this is Nevenka. We notice she goes to a maximum depth of 18, and that only takes her 10 minutes. I notice here also that the scale is one box is every two, because it would go 4, 6, 8, 10, 12, counting by twos. Counting this way, this one actually counts by threes. So don't be fooled here. This is not 10, this is 9. 9 is a halfway point between 6 and 12. So Nevenka goes to 18 meters of depth. Juan takes even longer to go to 9 meters of depth. So that would tell us that Nevenka swims faster. She goes further in less time. Okay. How many minutes does Juan stay underwater? Well, I need to look at the dotted line for Juan, and I find that he resurfaces. His distance from the surface goes back to 0 after 22 minutes. So that's 22 minutes. And how deep does he go? Well, he goes to a maximum of 9 meters deep. So it's 9 meters. 22 minutes, 9 meters. Now, what are both divers doing 12 minutes after they begin their dive? So here's 12 minutes after they begin their dive, and we notice that they're passing each other. Cool. Okay, so we could say they pass each other. Others of you said Juan is still going down and he's almost at his maximum depth. Nevenka is resurfacing. She's coming back to the surface. These are also great observations to make here. Now, down here, how fast? When I ask you a question like how fast, I want a measurement of speed. Speed compares distance over time. Kilometers per hour, meters per second. In this case, we'll have a weird one, meters per minute. So we want to know how fast she moves between 10 and 14 minutes. So that would be from this point to this point here. So we can label our points. This is the point 10 minutes, 18 meters. This is the point 14 minutes, 0 meters. And then speed will be the rise over the run. So going from 18 to 0 means she's traveled 18 meters. And how long did it take? 10 minutes to 14 minutes? That's 4 minutes. So I would say this is 18 meters over 4 minutes. And that's equal to 4.5, or 9 over 2 if you use a fraction, but 4.5 would be ideal here, meters per minute. Let's keep going. And I'll talk briefly about this one. You were asked to do one or the other of the questions, and I want to speed up a little bit. Here, Mario and Luigi are represented by different lines, and I notice that there are not lines everywhere. Luigi's is the dotted line. How do I know that's the dotted line? He has a head start. He doesn't start at 0, he starts at 1. Okay? Luigi has a head start, and his cart accelerates faster. Notice he achieves his top speed, which will then have his speed be a line. His speed is no longer changing, so it becomes a line instead of a curve. His becomes a line faster. This uptick happens quicker. Mario accelerates slower. He's still achieving his top speed, but then he achieves his top speed and keeps going at a line there. So Mario's is a curve for longer, and he doesn't have a thing. So that's why Luigi is dashed and Mario is solid. Okay, Mario is a solid line. When will one racer pass the other? Well, they pass when the two lines intersect. So they pass at 15 meters, and this is exactly at the halfway point between 10 and 15, or 12.5 seconds. I accepted 12, I accepted 13 as answers, so no problem there. If you were like, oh, that's 12, that's 13, it's 12.5. It's exactly halfway between 10 and 15. Okay, so they would pass each other at 12.5 seconds, 15 meters. That's a point in time and space. So what's Mario's average speed between the start of the race and the moment he and Luigi are next to each other? Whoa, sorry, that was louder than I needed it to be. To find the average speed, you're just going to go ahead and find, here is where they pass each other. His average speed is just from there to the starting point, okay? You just use this line and find the average speed over that whole time is the slope of that line. So that would be 15 over 12.5, which gives you 6 over 5. 6 over 5 is his speed. So you just do the rise over the run for that, which happens to be 6 over 5. Okay, where is it? Well, it starts from 0, 0. I'll show you the work. And it goes to that point, 12.5, 15. And so that's a rise of 15 over a run of 12.5. And that's equal to 6.5. Sorry, 6 over 5. Or for those of you that said 1.2, that's also correct. Answers may vary if you had a different number there, which I would have also accepted. Luigi's top speed in meters per second. This is the trickiest question because you need to recognize that he achieves his top speed here where his speed becomes a line, and that line represents his top speed. So you need to find the slope from the 0.55 all the way to there. I'm not going to answer that question. That was definitely like the level 4 question in this question. And then this one, and so yeah, answers also may vary because that number may vary, but you want to calculate the slope from the 0.55 to whatever you believe their crossing point is. That's Luigi's top speed. Now, who do you think will win? The correct answer is Donkey Kong, because Donkey Kong gets the best power-ups. If you can justify your answer, I gave you a check mark. No one told me Donkey Kong, because no one got this right. All right. Now, this here was a very important set of skills. Finding the equation of lines in slope-intercept form. So find me the y equals mx plus b that are given by points or tables. And then evaluate different values of x and y is also a key skill. If I give you y, you should be able to find me x. If I give you x, you should be able to find me y. So let's take a look at the different ways this skill showed up. Find the equation for this relation here and fill in the missing x and y values. So people need to read questions carefully. Find the equation is the first task, and it means also fill in the missing values. Here's a missing value, there's a missing value. Okay? The values may or may not be in order, and this one is not in order. Some people told me 9 because this is growing by 2 each time, but 9 is not correct. Because if I do put 9 in here, this should continue. 9 would give me -8, but I don't get -8 here. So when I analyze this table, I see that I have a few partial points and a few complete points. This is a complete point, and these two are complete points. Because those 2 points are adjacent, they're probably the easiest to work with. So let's take a look at the rise and the run. Here, this went down by -4, as this went up by 2. So my m value will be the change in y over the change in x. -4 over 2 happens to be the number -2. Always reduce your fractions here. It makes things easier. So now I know that instead of working with y equals mx plus b, I can add more detail to this. And I can say that this is y is equal to -2x plus b. One moment. Okay, carrying on. So we now are on the hunt for this number b. B here is a variable, but I should be able to determine it. B will be the y-intercept of this line, it will be where the line touches the y-axis. If I walked this back from 1 to 0 and then found the y value here, that would be b as well. So let's go ahead and find that. So one thing I can do is feed it one of these points. I could feed it any of the points, so 5, 0, 7, -4, or 1, 8. So I'm going to choose one that looks easy to work with. 5, 0 looks fine. So let's use 5, 0. Okay, so I might write down this point here, 5, 0, and then sub it in. 5 is x, 0 is y. So I put in 0 for y. 0 equals -2 multiplied by 5 plus some number b. 0 equals -10, which is a result of -2 times 5. And then I need to add some number to -10 to make it 0. So maybe I can see it right away. -10 plus 10 does equal 0. Cool. That would be b. There's b. Or if I don't know, then I still have b there, and I add 10 to both sides. And then I would have 10 equals b as this next line. So b equals 10. So now I know I have done the first thing, finding the equation for this relation. I need to write this out. Some of you don't write this out. You need to write it out. Y equals -2 is m, multiplied by my inputs x, plus 10 is b. Circle it. Put an arrow towards, I found the equation, Mr. Jennings. Just make your test easy for people to mark, and they'll be happy as they mark your stuff. Okay? Now let's fill in the missing values. I want to know what's the y value when x is 3. I can use my table, and I could say, well, it would be something that I have to take away 4 from to get 0. So that would be 4. Or, because 4 minus 4 would get me to 0. And then I'd have 4, 0, minus 4. And I see that's walking down. And why can I do that? Because this is also plus 2. Okay? And this is plus 2 here. So this would be 8 minus 4. Gives me 4. See how that creates a linear relation. Or I can use my equation. So I say x is equal to 3. I want to know what that is. And I say y is equal to -2 times 3 plus 10. Also 4. Lucas? Keep going? Okay. So -2 times 3, -6. -6 plus 10, 4. All right. Now, how about this one? What value will output 34 for y? Okay, so y is 34 at some point, and I need to find the associated x value. So let's use our equation. I'm going to use another color here for this question here. Orange. For 34, 34 is equal to -2 times x plus 10. Now I want to isolate x. I want this equation to be x equals a number. So move all the numbers away from x. Get all of its dance partners to the other side of the hall so that they can all stare back and see what x is when he's all on his own. So I'm going to subtract 10 from both sides. Move the loose addition first. Then I have 24 is equal to -2x. And that's already a lot easier to solve than this, right? Subtract 10 from both sides. 10 minus 10 is 0, so I don't write plus 0 there. And now I see -2 times x. Use multiplication, use division to undo multiplication. Use addition and subtraction to undo each other, and vice versa. That's the important thing here. So here, -2 times some number is equal to 24. So I divide both sides by -2. To get 24 divided by -2 will be equal to, these cancel and just give me x. I ran out of space. So anyway, -12 is the result of 24 divided by -2 is equal to x. Yeah, and I think you saw me highlight that, right? Yeah, -12. And so I kind of just look at you like this through the paper as you do that. Now you might say, oh, I almost got it. I was almost there. I had 12. I didn't have -12. No, you were wrong by 24. That minus sign is the most important detail for a lot of numbers. $1 million is a lot different than -$1 million. Do you agree? Yeah. I'd much rather have $1 million than be $1 million in debt. It's a much bigger difference than saying the difference between 10 and 40. So when you make that mistake, the important thing to do is to say, how can I avoid that mistake in the future? Well, that's a way to beat yourself up. Take a look at how the mistake happened without judging yourself as a human being, and say, I understand that mistake happened for this reason. I'll undo that mistake in the future by doing things slightly differently. Now, Deepan is working with this line here, and he wants to know the slope of the line and its y-intercept. The slope of the line is the m. It's the rate of change of the line. As x changes, y will change based on this number. That's the slope. So the slope is -4/3. And the y-intercept, this line will touch the y-axis at 1/3. Another word for y-intercept is initial value. What's the value of y when x is 0? In this case, 1/3. Yeah. So now Deepan wants to find the value of y when x is equal to 6. So here, this is a test of your fractions, but it's also a test, can you find me these values? So let's take a look how we do this. So if I want to know y when x is 6, I need to start with my y equals -4/3x, but I can substitute 6 in for x, plus 1/3. Now, some of you need to review how to multiply fractions. Others need to review how to add and subtract fractions. I will try and expand both of these practices as much as possible right now so that you see how to do this. 6 is the same thing as 6/1. 6 whole pizzas. Some of you use 6/6 here, which is not the same thing. That's a pizza cut into 6 slices, and you eat 6 slices. You ate 1 pizza. So you want actually pizzas cut into 1 slice, and you eat 6 of them. You ate 6 whole pizzas, so 6/1. -4/3 times 6/1 is 8. How do I know it's 8 in my head? I see that 6 divided by 3 is 2. 2 times -4 is -8. Did I say it's 8? No, it's -8. Okay? But I can keep this as over 3 because that would be handy for my common denominator by multiplying top times top over bottom times bottom. This is how we multiply fractions. Top times top over bottom times bottom. Y is equal to -24/3 plus 1/3. Now I do a quick check. I already have a common denominator, so I'm satisfied with that. I don't need to change the denominator. Then I do -24 plus 1 is the same thing as 1 minus 24. The answer is not -25 because that would be -24 minus 1. Further negative. So you imagine a day that's -24 degrees, but then it gets 1 degree warmer. It'd be 23, -23. So the answer here is y is equal to -23/3. For those of you that told me that it's -7 2/3, that's also correct. -23/3 is absolutely acceptable as well. Now, what about y when x is 10? Let's take a look at this one. So here we have y is equal to -4/3 multiplied by 10 plus 1/3. 10 times -4, well, that'll be -40. Y is equal to -40/3 plus 1/3. Same idea here. -40 plus 1 is y is equal to -39/3. And then checking 39, I add the digits 3 and 9 and get 12. So I quickly know that this number is divisible by 3. So this is actually a whole number. -39 divided by 3 is -13. Circle it, final answer. Now, what if x is a negative number? Well, let's input it again. Y is equal to -4/3 multiplied by 0.5, but it's negative, plus 1/3. A negative times a negative gives me a Positive. Now, 0.5 is the number 1/2. So I can use 1/2 here, or I can just multiply top times top. Same idea. This is 0.5 over 1. You'll find that's exactly the same thing as negative 1/2 in this case. So 4 times 0.5 will give you 2. Negative 4 times negative 0.5 will also give you 2 because the negatives cancel. So this is 2 over 3 plus 1 over 3. Y is equal to 2 over 3 plus 1 over 3. 2/3 plus 1/3 will give you 3/3. Y is equal to 1. Okay. Now, what about x when y is 0? Now, for this one, we have to put in 0 equals negative 4 over 3 multiplied by x plus 1 over 3. Okay. We're told y is 0 in this case. So now we need to find x. In this case, subtract 1/3 from both sides. So I have negative 1 over 3 is equal to negative 4 over 3x. And now I can multiply both sides by the reciprocal here. Multiply by 3 over negative 4. Multiply by 3 over negative 4. I think this is the most elegant way to solve this type of problem. This will save you some work, some time, and 10 academic is when I have a fraction here that I want to remove, just multiply by its reciprocal. Flip the fraction and multiply by that, both sides of the equation, because your 3 will cancel your 3 because one's on the top, one's on the bottom. Your negative 4 cancels your negative 4. One's on the top, one's on the bottom, just leaves you x equals on that side of the equation. Over here, notice the 3 cancels the 3, the negative cancels the negative, and I'm left with 1 over 4. So the answer here is 1/4 equals x. Done, final answer. Now, Muhammad is busy considering a line that joins these points. So I suggested that you graph the line as a way to... Oh, Landon, you have a question? Yes, sir. So here, graph your points. This is x, this is y. So I go over 2 in the x, 3 in the y. That's the point 2, 3 right there. And so graphing these points is very critical to getting these types of things right. And it's a critical skill for grade 10, any level. And then negative 6, negative 1. So I go negative 6 in the x, negative 1 in the y. Because of the weird feature of this graph paper where we don't see those lines there, many people put this point down there for some reason. It's not down there. It's at negative 1. And then I draw a line that connects those points, and I find, oh, it looks actually very regular. It's hitting integer points every 2. Hits this point, hits that point, hits that point. Cool. And I can actually solve the equation just by looking at the graph at this point. I can see that the run is 2 and the rise is 1.
What's that? What's that, Mr. Jennings?
What?
What's that?
What's what?
Never mind. What's the formula?
Y equals mx plus b?
Yeah.
Yeah. 1/2 x plus 2.
Beautiful.
Yeah, so here I see the b is where it crosses the y-axis, and I see the rise and the run. This is an increase in 2 and an increase in 1. Note the signs. Get your signs right here. Just going to zoom in. I'm just going to zoom in here. There we go. So you want to notice my x's are getting bigger in this direction, so that's an increase of 2. My y's are getting bigger, so that's an increase of 1. If I flip it, if this was going down, that would be a decrease of 1 in x. In y. So I want to make sure I have those signs there. Both of these are positive. So let's carry on. I can also find these algebraically using these 2 points. And I'll show you that for the next question. So graphically, I know this is y is equal to 1/2 x plus 2. I know 2 because that's where it crosses the y-axis. This gets a lot more complex if you misgraphed your points. So take a look at that. Now, what's the value of y when x is 6? Graphical solutions are also possible. I extend this over here to x is equal to 6, and I find y is 5. Y equals 5 graphically. And then what about this one? What's the value of x when y is 0? So I find y is 0 here, and I go back here, and I find x is -4. X equals -4. And just do it graphically if you can. If you want to check algebraically, that's also fantastic to check your work. You'll find it works. I'm not going to show you right now because I'm going to show you this one here. So again, I'm going to use graphical. I'm going to start by 6, 5. So 6 in the x, 5 in the y. Stick that point on there. And -4, -1. And then I join these with a line. I use a ruler to do so really accurately. And that's the best I got because I don't have a ruler in this program, unfortunately. But it looks like it might go through that point there, or maybe, I don't know. Let's see. What's our rise and our run? So we can use algebraic for this one because graphical, yeah, this isn't an integer in here. I know my b is going to be between 1 and 2, but that's all I really know from this. So I need some algebraic backup to find my equation of my line. So my m is equal to rise over run. And rise is going to be my change in y. And my run is going to be change in x. Okay? So my change in y, I go from -1 over here up to 5. So that would be an increase of 6. This is 6 here. 1, 2, 3, 4, 5, 6. And then my run, I go from -4 to 6. So that's 10. 6 over 10, always reduce the fractions to make things easier to work with. Remove the superfluous factor 2. Both 6 and 10 are divisible by 2, so divide both of them by 2. And then you get the m is equal to 3 over 5. So now we know that y is equal to 3 over 5x plus some number b that makes it true. Feed it one of the points, and that point looks easier to work with. There's no negatives? Fantastic. We'll work with something with no negatives. When y is 5, x is 6. So 3 over 5 multiplied by 6 plus some value b. So this is 18 over 5. And I'm going to make 5 25 over 5. I'm going to create a common denominator here. 25 over 5. I am going to subtract 18 over 5 from both sides. Where'd that number come from, Mr. Jennings? 3 times 6 is 18. 5 times 1 is 5. So this is 18 over 5. I subtract that from both sides. I make 5 with a common denominator. 25 minus 18 over 5 is equal to, well, 25 minus 18 is 7 over 5. So that's 7 over 5, and that's equal to b. B is alone over there. So b is equal to 7 over 5. So I know my line is y is equal to 3 over 5x plus 7 over 5. And I'm going to check with my graph just to see if that looks good. So if I increase by 5 here, I should increase by 3 here. And here it is. Increase by 5, increase by 3. This point is actually on the line. Doesn't quite look like it, but it is indeed on that line there. And then, could that be the point 7 over 5? 7 over 5 is bigger than 1, smaller than 2, so it fits the bill there. And so graphically, it looks pretty solid that my algebra is correct. And this is the right answer. This question was worth a bonus point because it's gross. I'm not going to show the solution to this one. Yeah? Baseball?
Yeah.
And you knocked it out of the park.
Yeah.
Fantastic. Yes, you did. Okay, so if you found this one, some people use decimal approximations to avoid the ugly fractions. I like it. Cool. A decimal approximation is going to be good here. If you use fractions and got to the correct answer, fantastic. If you want help on this question, come see me individually. Drawing something mathematical here, several people did that, and it was fun. So thank you for doing that. Now let's take a look at some of these applications questions. This one is one that you'll, see is quite relatable. We see Anna and Amar are both depositing money in their banks, so their bank balance is going up. It's important to note that we don't know how much they started with. We know how much they have in month 2. Anna's table is increasing by 1 each time. Amar's table is not. Amar's jumps over month 4. So that was tricky for some people. So you got to pay attention to that. This is increasing by $20 each month. And so that's constant. That's a line. This one increases by $15. $15 is how you write money. And then this one increases by 30 for some reason. Oh, because this went up by 1 and this went up by 2. That's why. So 2 times 15 is indeed 30. So we know that Amar is depositing a solid $15 per month in his account. I know that Anna is depositing more money each month because she deposits $20 per month. Amar only deposits 15. And last time I checked, 20 is bigger than 15. Okay, who started with more money? Well, let's figure out how much money they had in month 0, their starting month. So if I create equations, I could do this with equations. I could also walk the table backwards to 0. So let's start with Anna. In month 2, she had, what was it, $80? No, $60. So she's at $260. If I go back 1 month, that would be 40. And if I go back to month 0, that would be 20. Because she deposits $20 each month. So there's how much she started with, $20. Amar, in month 2, he has 90, I think, right? $90, yeah. And so in month 1, he must have had 75, and in month 0, he would have had 60, because this wants to add $15 each month. So I could use a table here to find that Amar started with more money. I could also use an equation, and the B value would give me their initial value, would give me how much money they had. So there's a few different ways to answer that question. Now, will they ever have the same amount of money at the same time? There were a variety of answers, and the correct answer is yes, they will. Okay, several people walked the table up until they found this, that in the same month they would have the same amount of money. If you walk both tables up just to the 8th month, you find that in the 8th month they have $180. You could also graph them and see that they will cross, and they cross at they cross at 8 months, $180. Or you can just use logic and say Anna is growing her money faster, but she starts with less money. So she will eventually catch up. Because she catches up, there's going to be some point where they cross. If they cross, that means at some point they probably have the same amount of money. And I accepted that logic without finding the correct answer because you were able to tell me why they will have the same amount of money. I'm going to show you algebraically how to do this. This is y is equal to $20 per month. X is the number of months plus 20. That's Anna's initial money. And y is equal to $15 per month plus 60. That's Amar's money. Okay? If I say 20x plus 20, will that ever equal 15x plus 60? Yes, it will. Move all the numbers to one side, subtract 20 from both sides. Move all the x's to the other side, subtract 15x from both sides. Then you will get this equation. 20x minus 15x is 5x, equals 60 minus 20 is 40. Divide both sides by 5, x is equal to 8. Therefore, in the 8th month, they will have how much money? 20 times 8 is 160. 160 plus 20 is the same thing as 15 times 8 is 120, plus 60 is also 180. So x is equal to 8, y is equal to 180. They have the same amount of money. Cool. This question was hard. This question I was looking for, can you extend your learning to take on a question that might algebraically be a little bit beyond you, but logically should be available to you? When will Roma and Jules be at the same place? And I gave you a hint down here was this map. They want to know when they will cross each other on the 401, but one is driving a little faster than the other. Just a little bit faster, you see? They're driving in opposite directions. Jules is coming from Montreal. Roma is coming from Toronto. If I'm coming from Montreal towards Toronto, and you're coming from Toronto towards Montreal, we're going to meet in the middle. That's a logical answer. If Montreal, if I'm going 120 and you're going 100, well, I'm going to meet a little bit further that way. There's your answer, Kingston. So for those of you who said, I don't know, but it's around Kingston, I said, high five, good use of your intuition. Okay. Now you see if you can use algebra to back up your intuition, or you can use graphing to back up your intuition. The way to set this up graphing-wise is you could go ahead and say, Mr. Jennings, I need a page of graph paper, and I would get you a page of graph paper. But here's the real key. Why this is distance from either Toronto or Montreal will work. Call it distance from Toronto. Because we need to distinguish travel in opposite directions will mean the sign is opposite for your speed. Okay? One is negative, one is positive. And that will solve the algebra problems that many of you encountered when you just compared distance traveled to time elapsed. Okay? Distance from Toronto, here is one way to set it up. We know that Montreal is 600 away, so that's where Jules starts. Jules goes from Montreal to Toronto at 120, and we'll do another color for Roma. Roma's traveling from Toronto at 100, okay? So then we have distance from Toronto compared to time. A quick check shows me that it will take Roma 6 hours at 100 kilometers an hour to travel 600 kilometers. So I need to be able to show time is 6 here. Roma will start at Toronto and reach Montreal at time 6. Go. So there's Roma's line, okay? Jules, well, a quick check shows me Jules at 120 will take 5 hours to travel 600 kilometers. 5 times 120 is 600. Or 600 divided by 120 is 5. So that gives me 5 hours here. So let's do this. This is 6, this is 3, this is then 4, this is then 5. Isn't my scale lovely? Oops, 2, and this is 1. This is an approximate scale. It's going to be good enough for my purposes. Here is the blue line that's going to take Jules from Toronto to Montreal. That's where they should blow a kiss. It happens just before 3 hours. That confirms our intuition. It's just before the halfway point for Jules's travels here. It's in Kingston, just before the halfway point again. And what's the distance? Well, I would need a piece of graph paper to do this more accurately, but it's a little bit less. We see this is bigger than this. So it's a little bit less than halfway between Toronto and Montreal. Kingston, about Kingston. And algebraically, if you want to talk about it algebraically, I'd be happy to chat with you about that later. Okay, last page. Very important skill to have. You're assumed to know how to do this at the beginning of grade 10, and you will be building on this in grade 10 the whole time, graphing lines. So I can very quickly graph these lines in the following way. This one here is y is equal to a slope of 3 multiplied by x minus initial value 3. So initial value I start with, I put that on there at minus 3 in the y. This is the b value here. Okay, and then a slope of 3 means, I'm going to zoom in here to really show you very clearly. I run 1, I rise 3. That's a point on the line. I run 1, I rise a further 3. So that's a point on the line. If I run -1, I rise -3. So that's also a point on the line. And I can actually put all the integer points on here very quickly. There's only one more to do. It's that one. And so those are all the points that are on this line. Slope tells me rise over run. So 3 is equal to 3 over 1 is equal to rise. How much does y change compared to how much does x change? Rise over run. You need this skill. So there it is. And then I just graph it. If I forget that skill for some reason, I can also graph this with a table of values. And I would say x values, y values. And I would test the following values: -1, 0, 1. And this will do. 3 times -1 is -3. -3 is -6. That's this point here. -1 in the x, -6 in the y. 3 times 0 is 0. -3 is -3. That's this B point here. And then 1, 3 times 1 is 3. 3 minus 3 is 0. So the result is 0. That's this point. So a table of values can also guide me to a set of points that I can put a line through. And that will be the line for that. This one here, I first look at the B value, which is +4, and I plot that. And then I go rise of -1, run of 2. So I run 2, I rise -1. Aha, there's another point on this line. And then further points will also be run 2, rise -1, or run -2, rise 1. Run -2, rise 1. And that will be the line that joins all those points. Their intersection is the solution. 2, 3. You got to write it down. You got to show me that you know how to interpret that point of intersection. Then find the intersection between these lines. But Mr. Jennings, they're not in y equals mx plus b form. Aha. We can convert them to y equals mx plus b form is the simplest way to go. So let's do that. This one introduced a very common sign error. So I'm going to walk through this one very carefully. X minus 2y equals -8. I want y equals and then all the rest of it over there. The first thing that I'm going to move is this x term here. I'm going to subtract x from both sides. X minus x is 0. So that gives me the next line, -2y. And I changed my voice there because many people lost this negative as you went down to the next line. It's not 2y equals -x minus 8. That is not correct. It's -2y. This negative still persists even though the x disappears. Okay, so now let's keep going. -2y equals -x minus 8. Now I divide both sides of the equation by -2. Notice I divide the whole side of that equation by -2. So now I have y equals, hooray, -x divided by -2 is x over 2. There's no such thing as the double negative in math. The double negative is a positive. So it's just x over 2. Don't say -x over -2. That would be weird. So x over 2 plus, because -8 divided by -2 is +4. So this is y is equal to x over 2 plus 4. There's my b value. My run is 2, my rise is 1. My run is 2, my rise is 1. X over 2 is 1x over 2. Run 2, rise 1. And then -2, -1, -2, -1, -2, -1. Okay? So those are the points that are on this line. This was the level 4 problem, by the way. Do you have all the skills? This one here requires even more doing. Okay, so let's convert that one in a different color. First thing I'm going to do, subtract 7x from both sides. And then I get the equation 6y is the only thing left over there, is equal to -7x minus 36. And now I divide both sides of the equation by 6. So y is equal to -7 over 6x minus 6. -36 divided by 6 is -6. So I go ahead and I plot this -6 on here. There's my b. And then I see -7 over 6. So I rise -7 and run 6. Note that -7 over 6 is equal to 7 over -6. Ah, that I can show on this graph. I rise 7. So if I rise from -6, 7, I'm going to go up to 1. And then I run -6. Oh, there it is. There's my point of intersection. Here's the line, goes through here, and it comes down, goes through there. That's not a very straight line, Mr. Jennings. I know. It's not very straight. You had access to a ruler, so that is that. Okay, so that would be the line that joins those 2 points. You have to write down the solution. The solution is -6 in the x, 1 in the y. So this is the point -6, 1. Okay, circle it. Write it all over your page. Say, I got it, Mr. Jennings. This would be a good spot for it. -6, 1. Circle it. Put an arrow on it. Say, see, so that it's really easy for me to see that you found the correct answer. Okay, actually, I just look at your graph and I know if you found the correct answer right away. So those were all the skills. There's all the skills in this unit. In grade 10, you're going to take these skills, you're going to review them, and then you're going to build on them. The line is going to start bending and hitting a wide variety of points in curious and interesting ways. You're going to be able to describe a lot of natural phenomena once that line becomes a curve. But humans love to create lines. Dollars per hour, kilometers per hour, the straight lines that define this room. All of these things are very human. We don't see a lot of straight lines in our world, particularly because there's gravity, pulling on things, bending things. But sometimes you see straight lines. A laser would be an example of a straight line. And in video games, probably bullets travel in straight lines. You would probably be modeling in three-dimensional space the path of a bullet in one of your shooter games with lines like these, and programming them in computers and a variety of different things. So these skills, not only are they useful to pick the best cab ride or how long it's going to take to fill your pool at a constant rate, these types of questions, but they will show up in future math quite a lot. So thank you for showing up for your learning. Any questions, absolutely come find me in person or by email, and I hope your math practice is fruitful today.